Today we're diving deep into Openclaw. It's an open source framework that's way more than just another AI model. It's a complete agentic runtime. We're going to break down the architecture that gives a large language model the hands and feet it needs to actually execute code, manage files, and just live on a machine. This is what turns a passive chatbot into an active, autonomous system.
This analogy is just perfect. It frames Openclaw not as some polished, ready-to-go product, but as a foundational architectural pattern. Think of it as the blueprint. It's a standard, repeatable way to build systems where AI's brain is directly wired into real-world action. That's the core idea we're going to unpack today.
All right, so here's our game plan. To really get Openclaw, we're going to build this up from first principles. We'll kick things off with a big problem all AI faces, this brain-in-a-jar limitation. Then, we'll dissect the Openclaw architecture piece by piece to see how it cracks that problem. We'll look at how it iterates all by itself, cover the absolute must-know security rules, and then zoom out to see what this new agentic era is all about. Okay, let's jump in.
So to really appreciate why Openclaw is such a big deal, you first have to understand the problem it was designed to solve. For all their incredible power, most modern AI models are basically digital brains floating in a jar. They can reason, they can plan, but they have no real way to interact with the world. They can tell you how to write a piece of code, but they can't actually open a file and write it.
This right here shows us the landscape before Openclaw. On one side, you have visual agents. They try to act like a human by literally looking at the screen and clicking things. But this leads to what's called a grounding bottleneck. It's slow, it's clunky, and it breaks the second you change a button's color. Then, on the other side, you've got your CLI agents. Powerful co-pilots in your terminal, but they have session amnesia. The second you close that window, poof, everything they knew is gone. Openclaw's genius is that it operates as a headless background service, a daemon. Think of it as a little helper that's always running, which lets it be both persistent and proactive. It solves both of these problems in one fell swoop.
So how exactly does Openclaw pull this off? Well, the elegance of it all isn't in some revolutionary new AI model. Nope. The magic is in the architecture surrounding the model. It's the system that's designed from the ground up to give that AI brain a body it can actually use.
Okay, at the very heart of Openclaw is this concept of an agentic runtime. This is probably the most crucial thing to get your head around. Openclaw is not the AI model. Let me say that again. It is the operating system for the AI. It's the infrastructure, the central nervous system, that connects the LLM's abstract thoughts to the computer's limbs, the file system, the command line, all of it.
The first piece of the puzzle is the gateway. You can think of this as the agent's universal translator or its multi-channel front door. It hooks into all the places you already are: Telegram, Slack, WhatsApp, you name it. And from an engineering perspective, this is a huge deal because it abstracts away all the messy, specific details of each platform. It just hands the agent one clean, standardized message to work with.
Next up, of course, is the brain itself, the large language model. And one of the smartest design choices here is that Openclaw is model agnostic. It doesn't care which LLM you want to use. You want to plug in GPT-4 for raw power? Go for it. Prefer Claude for more nuanced tasks? Easy. Want to run a Llama model locally for total privacy? No problem. This modularity is awesome because it puts you in control. You get to pick the right brain for the job every single time.
Okay, now this is where the magic really happens. This is the execution layer, the agent's hands. Here's how it works, and it's brilliantly simple. The LLM comes up with a plan and just spits out the code to do it as plain text. The execution layer then grabs that text, saves it to a file, and just runs it. That's it. This is what gives the agent its fingers, the real ability to manipulate files, run shell commands, and automate a browser.
So, remember that session amnesia problem we talked about? Well, here's how Openclaw solves it. Instead of using some complex database, it uses plain old text files, specifically Markdown files. And this is a genius move because it means the agent's memory isn't trapped inside a limited context window. Its core personality, your preferences, your entire chat history, it's all stored right there on the disk. The best part? It's completely transparent. You can literally open the files and edit the agent's memory yourself.
And finally, we have the proactive engine. If the execution layer is the hands, this is the agent's pulse. It's what allows the agent to take initiative without you having to ask. It uses two simple mechanisms. One is a heartbeat, a simple loop where the agent just checks in on things every so often. The other is a cron system, which is basically an alarm clock for the agent.
You can tell it, hey, check my email every morning at 8 a.m., and it'll just do it. This is what elevates it from a reactive tool to a truly proactive assistant.
All right, let's follow a single command as it moves through the system. This 6-stage pipeline is what makes everything so reliable and audible. So first, the channel adapter standardizes the input. Then, and this is super important, the task enters a lane queue. Think of it as a single-file line. This prevents chaos, what engineers call race conditions. Next, context assembly builds the full prompt from memory. Only then does it actually call the LLM. The tool dispatcher is where the action happens, executing the commands. Finally, the response path sends the result back to you, and, this is huge for debugging, it logs a full transcript of everything to a JSON-L file. Every thought, every action. This treats the agent like a proper engineering system, not a magic black box.
Okay, so the architecture gives the agent a body, but what gives it grit? What gives it that relentless persistence to just keep trying on complex tasks? Well, that comes from a special mechanism called the Ralph loop.
The philosophy behind the Ralph loop is all about persistence over perfection. So imagine you ask the agent to write some code and then run a test suite. The loop, which is really just a simple script, runs the agent, checks the tests, and oops, they failed. A normal system might just give up, but the Ralph loop takes those failure logs, shoves them right back in the agent's face, and says, try again. It forces the agent to see the consequences of its own work and iterate, treating every failure as just another piece of data for the next attempt.
So what makes this so different from other agent designs? Well, a conventional loop usually stops when the LLM thinks it's done, which, let's be honest, is not very reliable. The Ralph loop completely flips that. It shifts control to an external script. The loop only terminates when an objective, verifiable condition is met. Usually this is just a specific string of text, like a secret password, called a completion promise. If that promise isn't in the final output, the scripture says, nope, not done yet, and forces another round.
So here's how that works under the hood. It's a clever little trick called a stop hook. So the user starts the loop, the agent does its work, and then tries to exit. But, and here's the key, a little script intercepts that exit signal. It acts like a bouncer at the door. The bouncer checks the agent's work. Does the output have that completion promise string? If the answer is no, the agent gets sent right back to work. And the coolest part is, it doesn't start from scratch. It starts from the new state of the file system it just changed. The environment itself becomes its long-term memory for the task.
Okay, let's talk about something incredibly important. We're about to give an AI the keys to the kingdom, the ability to write and execute any code it wants. That is a massive amount of power, and with it comes a massive amount of responsibility. So let's go over the absolute, non-negotiable rules for running this thing safely.
And here it is, the golden rule. The single most important piece of advice you will hear. Do not run this on your personal computer ever. Instead, you use a virtual private server, a VPS. It's basically a cheap, disposable computer in the cloud. Why? Because it's an isolated sandbox. It has none of your personal data on it. If the agent goes haywire and deletes everything, who cares? You just delete the instance and start over. It is the essential firewall between this powerful agent and your actual digital life.
Seriously, these rules are not suggestions. They are mission critical. Besides using a VPS, you have to run security audits regularly with the built-in tool. Only install skills you trust. You're letting them run code on your machine. Always use disposable service accounts, not your personal Gmail, to limit the blast radius if something goes wrong. Use a secrets manager so you're not typing API keys in plain text. And finally, log every single action to an external service. That way you have an immutable audit trail that the agent itself can't touch.
Okay, so we've been deep in the technical weeds. Let's zoom out for a minute and think about the bigger picture here. Because Openclaw isn't just a new tool. It really represents a whole new way of thinking about how we build things with AI. This is the crucial mindset shift. For the last couple of years, everyone's been asking, how do I build cool apps on top of an LLM? Openclaw flips that script entirely. The new question is, how do I give an LLM the tools it needs to build and integrate things for me? It's a blueprint where the LLM becomes the developer. Our role shifts from being the implementer to being the director.
So here's the bottom line. This architecture is open source. That genie is out of the bottle. The key takeaway today isn't just Openclaw itself, but the principles it represents. The agentic runtime, the externalized memory, the objective-driven loops. As this pattern spreads, the fundamental question we all have to start asking is changing. It's no longer, what can we build with AI, but what hard problems do we want our AIs to solve for us autonomously while we sleep?
And understanding this architecture, well, that's the first step to being able to answer that question.